All right, Integrated Math 3, quiz number 7, taken December 2nd, 2020. Question 1a, based on the graph, how many zeros does the polynomial function have? I'm going to answer this question in multiple ways, and I don't even need to use the graph. So, how many zeros? I'm actually just going to look at the degree here. The degree tells you how many zeros you have. In particular, here's an equation you had in your formula sheet, is the number of real zeros plus the number of complex zeros equals the degree. So if you have a fourth degree polynomial, that's how many possible zeros that we have. Okay, so the answer is 4. Here is a second way that you can figure this out using the graph. You can look at these green points, they call these turning points. Let's write that, turning points. They're kind of like the point in which you make a U-turn if you are driving. And the reason why they call these turning points is because I'm increasing, and then at that point, which is an extrema, max or min, in this case it's a max, then it turns to decreasing. So in this problem, I have 3 turning points. And the formula is the degree minus 1. So let's just say you don't even have a formula, you just have the graph here. You just solve for degrees. So I just add 1, and you'll have the degree to be 4. So a second way to show you how the answer is 4. And here is a third way that I know the answer is 4. You can look at the x-intercepts. So basically, zeros are how many times visually it crosses the x-axis. And if it shoots through or goes through the x-axis, then it counts as 1. So this, try that again. This is 1, 2, 3, 4. So that is a third way of showing you why the answer is 4. Okay, part B tells us now what are the zeros of the above polynomial function. Well, we can do this visually because we have not learned other methods. And basically, here on the x-axis, this is x equals -4. This one is x equals -1. This one is x equals 0. And this one is x equals 2. And so the only one that has that is choice C. Okay. This one works, that one works, this one works, that one doesn't work. So that's why it's not A. If you only have 2 of these and it doesn't tell you anything about multiplicity, then this would be a second degree polynomial. So not this one, and this would also be a second degree polynomial. All right, let's go over question number 2. Part A here says, which function has a local minimum of a value of -1? So if I go down to a y value, and I'm going to make my purple line there, does any of those graphs hit that purple as a low point? Well, the blue one does not, f of x does not. The g of x goes, that purple line goes through it, but it's not the low point. And if you look at h of x, here is a maximum. And then it goes this way and hits here. This is a minimum. There you have a max. Okay, so that means, which one of these? That would be h of x. Okay, part B. What is the minimum value of the g of x? So now I'm going to focus on the pink graph. And you'll notice in the pink graph that the low point here is this one. So I'm just going to highlight that, and you'll notice that the y value is -5. That was the clue I gave you guys. When you write the minimum, you are writing the y value. It's just a number. All right, let's move on to question number 3. Which function has 2 zeros? So actually the same graph as the previous problem. Which one has 2 zeros and an even multiplicity and a leading coefficient? Okay, leading coefficient basically says, when the a value is negative. And what that does is it basically just, it reflects it. Let's write that, reflects over the x-axis. Okay, which one is kind of turned upside down basically? And the only one that has that is h of x. But let's confirm that with the other clues. It has an even multiplicity. That basically means that at the x-axis there is a bounce. That's what even multiplicity means, right? There is a bounce to the graph, right? It bounces off, it kisses the x-axis and runs away. So we have that in here and here. Okay, and then the last clue is there are 2 zeros, okay? And the zeros are x equals -2 and x equals +2. So that kind of confirms why h of x is our answer. Let's move on to question number 4. Consider the graph of f of x. So there's the graph. It is a parabola. Which transformation shifts f of x to the left 5 units and up 2 units? Okay. Got to think back to your letters A, B, C, and D for transformations. And C, going to the left here, is a -5. And up 2 units is our D value. So D is a +2. And then you can just write out your transformation, right? So that'd be something like f of x equals a times f of bx minus c plus d. And then if I just put in those values, -5 is going to go, pay attention, right there. And then 2 is going to go right there. So then I'm going to have, my function is going to be something like this. I guess this would have to be a g of x. G of x, I don't have an a value, so I don't need to write it. No b value. So I just have x minus, now pay attention, did you see how I have that minus sign is outside of the yellow there? So the c value is -5, and then d value was 2. So then if you just clean that up, you'll have f of x plus 5 plus 2, and that would be letter choice C. Whoops. I wanted to highlight it. All right, question number 5. Which set, and this is actually from our skills practice, a set of functions has a product. So product means to multiply. That builds a quartic function. Remember, quartic is something to the fourth power. Hint, each function, okay, so now they're giving us a tip. Each function shown is degree 3 or lower, cubic, quadratic. So that's why you're building a set here. Okay, now it says select all that apply. Okay, so which one builds a quartic? So here, this is a linear, so you would have something like x equals -4. And the big idea is if you add 4 to both sides, you get x plus 4 equals 0. And then you could put that around in parentheses, and that has a multiplicity of 1. And basically in that problem here, you have, essentially you're multiplying x to the first times x to the first times x to the first times x to the first, which is, you add them all. When they're the same base, which is x, you're adding when you're multiplying, the base is the x's. You're going to add the exponents. So you'll get x to the fourth power. So this one does match. This is a quartic. Let's try B. Okay. In this one, this is a 1, 0. So that would be a linear, which is x to the first. Okay, this one is a cubic. How do I know it's a cubic? It has a squiggly there. So there you have, this is going to be x to the third. So that would be 3 plus 1. That would give you a fourth power as well. So that one does match. If you're ever wondering why on this one, this is, remember, 1, 0, x equals 4. This is a shoot through, that is x equals -1. We're still apart. And then, so that would only, and then here you would have your two imaginaries because they don't touch the x-axis, okay? All right, let's look over here. Okay, you have a quadratic. You have two quadratics, x to the second times x to the second. I know it's quadratic because it has a parabola, and that will give you to the fourth power. So C would also match. And then let's look at the last one here. You have a linear, which is, try that again. Linear is x to the first, and then a parabola or quadratic is x to the second, and this would give you x to the third. And this is not a fourth power, so I'm not going to choose D. So the answers for 5 are A, B, and C. Okay, number 6 is a little bit different. You're going to have to actually, it says sketch or draw. You're going to draw something. A set of functions whose product builds a quartic, so to the fourth power, and has zeros. Let's try to color code this. X equals -2. X equals 0. And x equals 3 with a multiplicity. Okay, so x equals -2 is right here, and I can draw a linear. X equals 0, I can also draw another linear, and then where it says x equals 3 with a multiplicity of 2, you can do a quadratic. And this is, and your linears and your quadratics, they don't have to essentially be they don't have to be positive like we have here, but the big idea is that this is 1, 0, 1, 0, and multiplicity of 2, that's 1 plus 1 plus 2 is your fourth one. And I got a bunch of graphs here because there's a bunch of combinations. Watch, you can have x equals -2, 0, and what would happen if I did something like this? Is that okay? Yeah, because that's 1. That's also 1. And then x equals 3. You can do the same thing, right? You can do a parabola. Or if you did it over here, same thing. You can have done two linears that go through the same point. And then at purple at x equals -2 and at 0. Does that make sense? That would be also a fourth degree polynomial. Any other combinations I'm missing there? Purple, -2, 2. So you have a quadratic, and then at 3, you can have something like that. Okay, let's see. Or you can just have 4 linears, right? 1, 2, 3, and 4. Oh, I already did that over there. Duh. So that's redundant. So a bunch of combinations, you can choose one of those. All right, question number 7. Which graph could represent the function f of x equals negative x to the third power minus x squared plus 5x? Okay, what I'm going to do is I'm going to just take apart this function and try to figure out all the things that I know, okay? Here in blue, this is called the leading coefficient, and it is negative. And basically what that does is it flips the graph. You can also think of it back in your transformations. A equals negative 1 is a reflection over the x-axis. Reflection over the x-axis, okay? So that's in blue there. Here in green, you have a third degree polynomial. Third degree polynomial. They call these cubics. And what you want to know from there is that this is a odd degree. Odd degree, right? The easiest one you know is to the first power. All right, something I also notice here is there's no number here without an x. And this would have been the y-intercept. So I know my y-intercept is going to be 0. Okay, so let's construct our own graph. This might be helpful. If I just construct my own graph. Let's construct our own graph. Okay, so like I said, the easiest we know is, usually starts down, ends up as you go left to right. But the leading coefficient here is telling me that it's switching. Okay. So we're looking at the blues now. And then a y-intercept of 0 is going to look something like this. Okay. So let me just go ahead and sketch that graph. I don't know, it might look something like this. The big idea is the arrows. Arrows are super helpful. Okay, so and notice I don't have all the other intercepts, the other x-intercepts, but the arrows are super important, okay? Watch. This one has a positive leading coefficient, so I don't need this one or this one. Now this one has negative, I should have done that in blue. This one does have leading coefficients, okay. So either A or D would be okay so far. And let's see if I can work with it a little bit. Let's factor out a negative x. If I factor out a negative x, I will get x squared minus x minus 5. Okay, what I did, I just took out a greatest common factor. Okay, so what's important in this part I just did is that this has a multiplicity of 1. Multiplicity of 1. How did I know that? Because x here is kind of hard for you to see. Let me see which colors. It's to the first power. Okay, why is that important? Is because if you set that equal to 0, set it equal to 0, and you multiply both sides by -1 or divide both sides by -1, you have x equals 0. And so both of the graphs have it, but you're looking at its multiplicity there. Remember, this is odd multiplicity, which is a shoot through. This is shooting through the x-axis, and this one is not. This one is doing a bounce or a kiss. So it's not D. Our correct answer is going to be A. I actually did this without using a graphing calculator. Okay, let's try question number 8. Reflect the function f of x equals x to the fourth about the x-axis. Okay, so here's the first one. Let's reflect it about or over the x-axis. Okay. That is an a value of -1. So here I'm trying to identify the characteristics to letters. Characteristics or the descriptions to letters. That's kind of like what I'm doing right now. Translate it 3 units to the left. That would be a c value of -3 to produce g of x, which represents the function g of x. Okay. Okay. So first thing I'm going to do is look for all of these that have an a value of -1. Yes, 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 yes. Okay. Those are good. Okay. Choices A and B, these are d values. So this one's saying d equals 3, and this one is saying d equals -3. How do I know that? Remember the transformation formula sheet that you have. Let me pull mine out. And the transformation we have is something like this. Okay, so did you notice that the C is inside the, let's try to make that obvious, the inner parentheses, which is green, okay? And choices A and B, there is no parentheses, so let's cross those off. No, no. Okay, here is the big one. Is it going to be a -3 or +3 inside? Well, I first want to highlight something, and I'm going to highlight this minus sign. This one always confuses students, so hopefully I make it clear. C equals a -3. So you're going to have something that looks like this, okay? A value, you can put it in 2, let's do that. A value of -1. F, there is no B value, so I don't need that second set of parentheses. I have X, and then C value was -3. And then there's no D value, so none, it goes away. None for B goes away, okay? And then you just clean it up. G of X equals, we normally don't write a -1, we just have a minus sign, F of X plus 3, okay? And that closely resembles D is your answer. And a quick way that would help you is a silly phrase, right? That I have. Try that again. Add to X, go west. So here is, let's make that clear. Adding to X is a plus sign. You're actually going 3 units to the left. Okay, that phrase right there is a trick. Okay, all right. Number 9, which function is even? All right, you could graph this, but you know we're meant to do these without a graphing calculator, so I'm not going to graph those. And then this is the problem where it's the star sub -x for every x. And basically what this is testing for symmetry. Test for symmetry algebraically, okay? And it wants to know what an even is. So an even basically says that you get the original function, okay? Let's do A. I'm going to put in a -x for every x value. And here I'm just going to use my order of operations, PEMDAS. So I'm going to use exponents. Negative x times negative x times negative x is negative x cubed. And negative 8 times negative x is positive 8x. And I'm just going to clean that up. So 6 times a negative x cubed is negative 6x cubed plus 8x. Okay, now this one has a negative. So if I factor out a negative 1, this is my greatest common factor. I get 6x cubed minus 8x. And so you'll recognize that this is the original. So this one's actually the opposite of the original. This one is actually an odd function. So it cannot possibly be a. Okay. Let's try another one. Let's try this one. Whoops, I wanted to use green. Let's try g of x. So now, g of x, we're going to put in negative x. And we're putting a negative x for every time we see x. And so 14, negative x to the 4th power is, no. Sorry about that. Negative x times negative x is x squared. And essentially x squared times x squared is going to be x to the 4th power. This is going to be positive. And another trick that if you're not understanding the multiplying of, they call them monomials, just take negative 1 and put into your calculator to the 4th power. But you have to be careful. You have to use parentheses. You have to use parentheses. Positive 1 is the correct. It's a positive answer. That's what I'm trying to point out. If you did something like this, the calculator actually has read it as 1 to the 4th power and take the opposite. Those two lines are totally separate. It gives you the wrong answer. Okay, so use parentheses. Okay. And then this would be negative 3x. So this would be 14x to the 4th minus 3x. And is that equal to the original? It does not. So we can say it's not equal to the original. And so this would not be an even. Okay. Let's try this one, m of x. M of x is this. And every time, again, we see an x, we're going to write a negative x. Now, don't be concerned about the left side. Don't be concerned about the left side. So negative x equals 9 times negative x squared plus 4. And I'm going to do negative x times negative x, which is x squared. So I have negative x squared plus 4. And that is the original. So you would actually write something like this. So this would be a even. This one up here in green, this was actually a neither. So this one is good. And let's just double check that the other one was wrong. Let's do this one in orange. N of x equals 7x cubed plus 2x squared. And so negative x equals 7 times negative x cubed plus 2 times negative x squared. This would be negative x cubed is negative x times negative x times negative x, which is negative x cubed. And this one is going to be negative x times negative x is just x squared. And if you just clean it up, it would look like that. Now, if you factor out the negative 1, you're going to get 7x cubed minus 2x. It's not equal to the original, and it's not equal to the opposite of the original, because this one has a negative sign there. So this one is a neither. So the only correct answer we have is C. And the last one, end behavior. Describe the end behavior. Remember, as you're doing end behaviors, it always goes left to right. Let's write out a couple tips for you. Left to right. And you always have this sentence frame. As x approaches blank, f of x approaches blank, right? And remember, this blue box is always the same. Always. You have one that's positive. That means as you're going to the x-axis this way, as you're going towards the right, what happens to the graph? And as you go towards the left, the other way here, where's the graph finish? So let's do this with words. As I go towards the right, the graph finishes up. Up is positive infinity. As x goes towards the left, where does the graph finish? It finishes what? Down. Down is negative infinity. Did you notice in red here that these are in opposite directions, which is an odd degree polynomial? Okay? And so if I match it up here, let's see which one that matches it. Positive, positive, negative, negative. That would be choice C. C is my correct answer. I hope that was helpful for you. See you guys.